So the last unit of Module 14 is about putting together all three ratios and what you've learned so far to solve triangles. And so that means finding all of the unknown sides and angles in a triangle. There are many ways to do these. One way to start, you can think about that rule that your two non-right angles have to add to be 90 degrees in a right angle. So that can often help you solve an angle. And then think SOHCAHTOA. So see what you know. See if you have an angle and a known side, or maybe two known sides. And then see what ratio you could choose to use to solve for a further angle or side. So let's do these first two together. So question one, we're asked to solve this triangle. We're given angle A is 40 degrees. So let's solve for angle B then, first of all, because we know that angle A plus angle B together must equal 90 degrees, since this is a right triangle. And angle A is 40 degrees. So if we subtract 40 from both sides, we get angle B as 50 degrees. So one thing solved. Good. Okay, where do we go from here? Well, where possible, I suggest using the information that's been given to solve further sides, because we could use angle B as our target angle, but if we made a mistake there, then it's just going to lead to downstream errors. So I always try to choose where what I know, what was given to me, where I can. So I'm going to make angle A my target angle. Relative to that angle, little a here is my opposite side, and B is my adjacent. So I know my opposite, I know my angle, and I'd like to know my adjacent. So let's use the tan ratio to solve for little b. So we know tan of any angle, maybe I'll just write little b here to show that's what we're solving for. And up here it was angle B. Okay, so we know the tan of any angle theta is opposite over adjacent. So tan of our 40 degrees is 5 over little b. Let's multiply both sides by b to get it out of the denominator. And now we have b times tan 40 equals 5. So let's divide both sides by tan 40 to isolate the b. And so that gives us b, it's 5 divided by tan 40. And pay attention to your rounding instructions. Here it says angles to the nearest degree, sides to 1 decimal place. So if I round to 1 decimal place, I end up with 6.0 here. So B equals 6.0. Okay, let's look back at our triangle. So the only thing we don't know now is little c. And we can either use SOHCAHTOA to figure out little c, or we could use Pythagorean theorem. Pythagorean theorem is probably the easiest way to do it. But one thing I've seen students do that I like is use SOHCAHTOA to solve for C, and then you can use Pythagorean theorem to double check. So I'm going to do it that way. Let's make it green. So we're looking for little c now. Maybe I'll put it here. Okay. And I'm going to go still relative to 40 degrees as my target angle. So then C is my hypotenuse. So I'm looking for a ratio involving my opposite and hypotenuse sides, which would be sine. So sine of any angle theta is opposite over hypotenuse. So sine of my angle 40 degrees is 5 over little c. Let's multiply both sides by c. So I have c times sine 40 equals 5. And then let's divide both sides by sine 40. And that allows me to solve for c. So when I put that into my calculator, I get 7.8 to the nearest tenth. And now, as a double check, we know a squared plus c squared, a squared plus b squared equals c squared. So if we want to check this, we can check if little a, which is 5, so 5 squared, plus little b, we found to be 6.0. And we're going to check if that equals 7.8 squared. So 5 squared plus 6 squared gives me 61. And 7.8 squared gives me very close to 61. There's a little bit of a difference. It's 60.84 because 7.8 wasn't an exact number, nor was 6.0. But yes, it checks out. So that's a nice way to double check your work. Okay, let's do one more together. So we're solving this next triangle here. And we haven't been given any angles. We've been given 2 side lengths. Let's start by figuring out the third side length, and I'm going to do that with Pythagorean theorem. So I know a squared plus b squared equals c squared. And we're trying to solve for b, so I'm going to subtract a squared from both sides. So b squared is c squared minus a squared, which is 28 squared minus 25 squared. And that gives me 159. So now I want b, so I'm going to square root both sides. And the square root of 159 to 1 decimal place is 12.6. Okay, so we have all 3 sides now. Now we need to know our angles. So let's start with angle A. Relative to angle A, I'm going to try to use the known information I've been given. So little a is my opposite side, and c is my hypotenuse. Okay, so we're looking for angle A. So if I know my opposite and hypotenuse, I want to use the sine ratio. So sine of any angle is opposite over hypotenuse. So sine of angle A then is 25 over 28. The decimal version of that is, I'm going to go out to 4 decimal places, but I'm also just going to store this on my calculator. So 0.8929. So if I take the sine inverse of both sides, I get A is the sine inverse of 0.8929. Oh, I guess I dropped my angle system. Okay, so I'm going to do sine inverse of the answer. And to the nearest whole number, I get 63 degrees. The last one we need is angle B. We can do that one of 2 ways. We could actually use SOHCAHTOA to figure that out, just like we did for angle A. If you do it that way, it's a nice double check that angle A and B add up to 90 degrees. I'm going to do it the easier way though, which is we know angle A plus angle B is 90 degrees. And we just solved for A. So we found A was 63 degrees. So therefore, if we subtract 63 degrees from both sides, we've got angle B is 90 minus 63. And that gives us 27 degrees. And always do a double check. Make sure you've solved all of the angles and sides. And here we have. So go ahead and try the rest of the exercises and come on back if you want to do them together.